Okay, cool. So back to 4.9. So we were solving systems. Let's look at this one, for example. Control plus. This is number 9. I think that's also new. So we have d squared plus 2x minus 2y equals 0, and then minus 2x plus d squared plus 5y equals 0. The system to solve. So any ideas? So we're going to try to use elimination, so cancellation. Can we, especially one way to proceed? How do I try to eliminate either x or y? Let's say I want to eliminate x. What should I do? Online students, how would I eliminate x or not online? What would I multiply to eliminate x? No answer. Oh, it's cancellation, like in your algebra, right? How do I cancel? So what if this was your algebra? 2x plus y equals 0. 3x minus 5y equals 0. How do I cancel the x? What would you multiply to cancel the x?
To multiply the top by -3.
All right.
Or yeah, and then the bottom by 2.
Yeah. Why can't we do the same thing here? What would you do? What can I do here?
Multiply by
The top by, let's say I want to cancel x.
2
2. And the bottom by?
d squared plus 2.
Right. So both sides, right? How would I, maybe I'll do this. Though that's a 0, but, you know. Okay. So let's see what happens at that. So the first equation will become, let me distribute this 2 here. 2d squared plus 4x minus 4y. 0. And that will be, maybe it would be better if well, let's do that. Let's distribute it. So what we have, 2d squared plus 4. And let me distribute this -2. That's gonna be what?
Minus 2d minus 4.
Yeah, maybe I put maybe that was not wrong. But maybe it will be better if I leave it like this for you to see. Let me, yeah, maybe I'll leave it like this. Maybe this is easy to see like that. Does that make sense? If I multiply it. And then I'm gonna multiply these and that. Let me for now keep it that way. Any questions so far?
Yeah, quick question. So the first equation is supposed to be the top one. The first one right there. So the 2d squared plus 2, that's supposed to be the top.
Oh yeah, I just keep the order, right? The same order.
Oh, okay, perfect, awesome. Thank you.
Sure. More questions? Then I'm going to add them. And if I add them together, I will eliminate the x. So let's see what is left. So once I do that, I will have minus 4y plus this. A little bit bigger. Oh, we can distribute this guy. Or FOIL that guy. That will be this. 2, 5, maybe that. And maybe that. Questions? Now, you can also think, I can kind of factor this y out. So what will that be? The negative 4 will, I don't know, should I do negative 4 plus 10 as a 6, or should I? Let me write that. Right? But that's the same as to. Now from here, there are two ways to think of it. One way to think of it, this is the same as fourth derivative of y. Well, let me just write it down. This and as we discussed it last time, that simply means fourth derivative, 7 times second derivative, and 6y. Questions there? That notation, as we discussed last time, means that the d is the tech derivative operator. Questions about that? We can solve this. Well, this guy has constant coefficients, so what is the characteristic equation? M to the 4 plus m squared. But you also notice this guy, if you compare this to this, you can think like, oh, that kind of could be also written like that. So you can think like, oh, just from here you can also write that. But this is like, and that is a quadratic, right? If you think like this, if you think like m squared is, I don't know, a k, so that's just the k squared plus 7k plus 6, right? So either factor or use a formula, but I think that's an easy factorable.
K plus 1.
So we have m squared what? Plus 1, m squared plus 6. Continue here. Let me see, I'm gonna need one of those equations, so I'm gonna keep this guy. And use this, I'm gonna keep that original equation. So I want to see, so I'm gonna continue here. So I have m squared equals -1 and m squared equals -6. So what happens here? We get here what? M equals what?
I. Plus or minus I.
Plus or minus I. And then of course we get what here?
Plus or minus 2 square root. Wait, no.
6 is a 6,
Yes,
2 times
yeah.
3, right? So 6i, can I write 6i? Okay. So let's see if we can write a solution for this equation, but that's just, it's homogeneous, but the whole thing is homogeneous, so we just basically found the y. But y, we should remember y and x are both a function of t. So how would I write that? Oh, let's look here. So here we have what? Alpha plus or minus beta I. So alpha is what?
0.
0, and for beta I'm gonna use what? And with the same thing here, maybe I should not write alpha and beta, but I will, is what? 0 and beta is what? 6.
Is this square root six?
Square root of 6. I was so wrong. It's a square root of 6. Questions from anyone? Oh, I don't want this to happen. There is somebody without name. JM, can I have your name, please? Can you change it, or you want me to change? JM, can you hear me? This is the reason I didn't. JM, can you hear me?
I can hear you. Sorry, I didn't notice it.
That's okay. If you can, you do it, or I can do it for you. Do you want me to change your name, or you want to do it?
Are you able to change it?
Yes. Just give me your name, please.
It's supposed to be Jenny, Jenny.
J-A-Y, right? Or J-E-Y?
Jenny.
Jenny. And then what was your last name, Jenny?
Moz, M-O-Z.
Thank you. Okay. Okay, cool. So yeah, we're gonna continue. So we got the oaths. So for what we're gonna have the following then.
Professor,
Yeah,
I came in a little late. Is this problem 9 in the book 4.9?
I believe so. Did I write it wrong?
Okay.
Yeah, I think-
I have it
No,
something
no.
else.
Oh, I'm so sorry. I'm so wrong. The problem, that's right. The number should be 5. 5, you're right. The problem is 5, but it's number 5, not 9.
Okay, thank you.
Yeah, it says 4.9. Cool. Because I'm looking at a website. I put it in your homework. I wanted to do this. Okay, cool. Okay. So from there, okay, so then we will have y of t equals, I think it was e to the what? Alpha, right? Maybe I write what? Alpha x, I write 0x, and then we have c1 what? Cosine of beta. Oh, but and I get wrong again because of x we have what? T, beta t, right? I just want to remind you this, that's why I'm writing like this. Sine what? Beta t. But then we have also those guys. E to the 0t. But I only have C1, C2, so I'm going to have C3. Cosine of beta. Plus maybe 4. C4 sine that. So let's just rewrite it maybe. So we got the y of t equals 1, so we have C1 cosine t, C2 sine t, C3 cosine this guy, C4 sine this guy. So what is left to find a what? The x. There's more than one way to continue from here, but what I've done last time, I plugged this into one of them that is easier to find the x. So what do you think would be easier if I replace the y by that to get the x? The equation 1 or equation 2? If I substitute that for y, which equation will give me x easier, 1 or 2? Any ideas? Which one is easier to solve for x?
Equation 2.
2. Why? Because this one in reality is what? This is second derivative of x, right? It's harder. But this has what? X just alone. So this is easy to solve for x. This is not. So I'm going to plug it in here. So I'm going to plug in the y in the second equation. Again, we could have also do the same thing and get the y, but I don't want to do that. I will explain why I don't want to do it soon, maybe. So, but in order to plug in here, this equation is actually this, which means it's required the second what? Derivative. So I have to take the derivatives of y. But these are easy derivatives, cosine and sine. So if I get the derivative of y, that's gonna be what?
C1 cosine t.
No, the derivative.
Okay. Minus C1 sine t.
Mhm.
C2 cosine t. Square root 6. C3 cosine. Square root 15.
Right. And then this one, right?
Square root 6, C4 cosine, square root 16.
Okay. And now we need to do one more time because it requires the second derivative.
Minus C1 cosine t. Minus C2 sine t. Minus minus 6 C3 sine square root 6t. Or cosine squared. 6 C4 minus 6 C4 sine square root 15.
Cool. So that's fine. So now we're just gonna replace what? The y double prime here and a y here, and then just solve for x. That's all what is, and then combine maybe things. That's what is left. So let's plug in, substitute. Let's substitute. So we don't need this anymore. So I'm gonna start from here. This is what I'm using. So I have negative 2x plus y double prime. So plus this guy. Let me do this. Let me write each term one under another, just maybe that will be easy to see. This is the first guy. Now I'm writing what? This guy, which is that. Minus. I'll just put here minus if you don't mind.
C3 cosine square root 16. Minus 6 C4 sine square root 16.
And then now I'm going to write this last guy, plus 5y. So I'm going to multiply this guy by 5 and add. I just put here plus 5.
C1 cosine t plus 5 C2 sine t plus 5 C3 cosine square root 6t plus 5 C4 sine square root 6t.
So that equals to what? Equals to, we are here, 0. Equals to 0. This whole thing, maybe I'll write here, equals to 0. So in order to solve for x, maybe it's easier to what? To move this guy to the other side. To get positive to x. Now, if you let me to do a little wrong thing, if you let me to do a little wrong thing, I'll just move it here like that. You may not like it, I don't know. Anybody understand what I've done? I mean, in the video, it may be seen because it's not a PDF, but it's a video. So this guy was on the what? Left side. I move it to where? Kind of the right side. If that makes sense. So, well, this is the left side, this is the right side. So what is left to do? Divide by what? 2. But before that, let's combine the what? Like terms. So let's see. We have cosine t here, comes some number. Cosine t some number. We have sine t some number, sine t some number. We have cosine radical 6t's. And then we have what? Sine radical 6t's. So let me write 2x equals. So these two together will give me what?
4C1 cosine T.
4C1 cosine T. Those two guys will give us
4C2 sine T.
Mm.
Minus C3 cosine radical 6T. Minus C4 sine radical 6.
I'll divide by 2. So we got x t equals 2C1 cosine t, 2C2 sine t, minus what? 1/2 C3 cosine this, minus 1/2. We don't need the derivatives. I need that y because it's part of my solution, but I don't need the derivative. So we got, this is our x. This is our y. Questions with that problem? Now, here's what I don't want you to do. You don't want to rename this C1. Here's the reason for that. Because if you rename this C1, then this guy becomes different. Because the C1 is the C1 here. You can remain this 1, 2, 3, 4, C5, C6, C7, C8, but we don't want that. I want you to have the same Cs. So if this was C1, why am I not renaming this? I can remain C5, C6, but I don't want it. I have the same C1, it's there. So C1 is here. If whatever number is this is double of that. That's what it means. Whatever number is this is double of that. Whatever number, this could be anything, but this should be half of that. That's the idea. Questions? Let's do another one. Let's do one with initial values. I think I already have it in your homework, but yeah. Oh, it's right here. So yeah, I do believe I have initial values. Yeah, there you go. Can look at this one or another one. This one is, maybe we'll look at another one. Similar. 21, but let's look at different. Go back to the book. Similar to your homework 21. So, oops, there you go. 4.9 will be the last thing in your exam, right? I think we discussed that last time. Okay, next exam. So going to 4.9, close to 21. 21 is this. So we'll look at 22. 22, but it's all zeros. Maybe what was 21? Yeah, it has like ones, but it doesn't really matter. Yeah, because 22 is the only one with initial problem, 21 and 20. So control plus, no, because it disappeared. I have to go back. Okay, so 22. Now we have a system. Dx dt equals y minus 1. And probably dy dt equals minus 3x plus 2y, and we have initial conditions that go with it. It is x at 0 is 0 and y at 0 is 0. So nice, easy conditions. Now we could solve it this way, but I want to use the same way as the book did for the, so we can do just only substitution, but this section is called elimination. So we'll do elimination. I also want to practice that notation. So this is gonna be with that D, the operator notation, dx minus y equals this. And so let me just put it x to that side with the x's. And then I have plus, this guy is dy, and this guy is minus 2y. But I don't want to have y and a y. I want to combine those.
T minus 2, y.
So with that d operator, I can write dx minus y is minus 1, dx plus d minus 2y. Now we can either eliminate x or y. I don't know which one is a little easier, maybe x. So how do I do that?
Multiply the bottom by D and the top by -3.
So let's keep the order of those equations. So the first one is minus 3 dx plus 3y equals minus 3. The next one is 3 dx plus d times that. So if we add, those guys will go away. So I'm going to add them, but at the same time, I'm going to distribute this d. We can also factor out kind of that y. So it's d squared minus 2d plus 3. Now you can get your characteristic equation from here, but I want to rewrite this as derivatives without d. Without d, it's what? Well, with d is this, which is the same as this.
Sorry, Professor, shouldn't that -3 be positive since you multiplied by -3?
That is so right. That is so right. That is so right. That should be positive. That is so right. 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 Anything else? Cool. And now we'll solve first the homogeneous equation. What is the corresponding homogeneous equation?
N squared minus 2n plus 3.
Right. So let's solve this first homogeneous, and then we get a particular solution for that. So you're right. M squared minus 2m plus 3 equals 0. That will give us what? Is it minus 1 minus 3? No. No. 3 and 1. Yeah, none of them will do. So let's use the formula. So minus b, right? Plus or minus what? B squared. Mhm.
4ac,
4ac, and then what is it?
2a.
2a. We see that's negative because that's 4 minus 12. That's why we couldn't factor. So we have 2 plus or minus, that's a 2 times 4, right? So that's a 2 rod, right? So 2 rod 2 I 1 and probably fact. So we're going to compare it to alpha plus or minus beta I. Questions for so far? Questions so far? Okay, let's see what's happening. I want to keep this guy. Oh, maybe I want to keep this. That's okay, I'll rewrite it. So let me just, can somebody give me the equation so I can keep it here, please? What was it, dx?
df dt equals y.
No, but let's
Oh,
after the, with the operator d.
um,
Dx,
minus y equals minus one.
and the other guy?
Dy,
No, but let's put the x here. First x.
oh, okay,
Well, and I ordered that.
3x,
3x plus,
dy.
No.
Oh, you want the
right,
d minus two,
d minus 2.
Yeah.
Y equals 0. Is that, can you check one more time, is that right? Like x is together, y is together, after I kind of arrange like that. Okay, cool, so this is the original equation and this is the conditions, okay. So now we have, alpha is what? 1, beta is what? Root 2. So maybe I will write the formula, this is the what? This is the y. So I will write formulas maybe e to the alpha x, just to remind you, c1 what? Cosine, oh, x is wrong, right? T cosine of beta t sine of what? Beta t. So let's just do y as a function of t, e to the what?
t,
T, 1t, c1 cosine of what?
root two t,
Root 2t sine of what?
root two t.
Root 2t. So this is not the y, I am so wrong. Because this is the solution of the only homogeneous equation. We still have to take care of the non-homogeneous, the yp. That's the complementary solution. So for the yp, we look at the right side, which is 3. So the yp will be most common number, a number, so we write what?
A,
A. We also have to check if there are no matches. So A, and there are no, well, I should have maybe distributed this e to the t. I'll do it maybe soon. So let me rewrite this by C. So C1 e to the t times this, C2 e to the t times what? This. I want to kind of write C1 times Y1, C2 sum Y2, kind of. But none of them is a number alone, so there's no match. So this is back to the undetermined coefficients. What if it was here plus another C3? Then that would be a what? Match. So I have to multiply this by T. Yeah, but we don't have that. Question so far. Okay, so that's an easy YP. We're gonna plug that into our here. Let me erase this. I want to remind you we are solving this equation, so we have to plug that into here. So we need up to the second derivative, but that's a constant. The derivatives will be what? 0, right? So we plugged in here. We have 0 minus 0 plus 3 times a. And that will give us the a is what? So that yp is 1. So y is yc plus p. So y is this guy plus
1, sorry.
1. Now, I don't need this anymore. I'm gonna erase this.
Professor?
Yeah,
Sorry, I got a little bit lost. So when we did the derivative of yp, why did we get a 0? Because yp is it's equal to a. Okay. Okay. Thank you.
Other questions? So now I'm going to add the 1 here. So we got the y. Now it's time to find the what? The x. So we go back here. Which one is easier to solve for x? The first one or the second? Second. If I do this, I will have to take an integral. But this has just an x. This is nice. So I'm going to use this. I'm going to plug in the y into there. But let me rewrite that guy. So the second equation is 3x plus dy minus 2y. Or 3x plus y prime minus 2y. So I need the y prime. I need to plug in the y here, y prime here, and kind of solve for s by dy. Cool. So that's the y. So let's see what is y prime. Unfortunately, we have to do a what? Product what?
Product
Cool. So derivative of this guy will be what?
C1 e to t.
C1 e to the t. Keep that guy alone. Then keep this guy alone. And do the derivative of this guy, which will be what?
Minus square root 2 sine square root 2t.
Right. So then we do product rule here. That times that, same way, right? Maybe I'll continue here. So derivative of this guy, leave this guy alone, leave this guy alone, and derivative of that guy.
Cosine square root 2t.
Let's just rewrite this, like just move the negative here and make it a little nicer. And also, I think there are things to be combined. No. So let me rewrite it. Y prime equals, where am I plug that into? Here. I don't know if you, let me do this. Let's start plugging in. And yeah, so I'm gonna plug that in into here, right? So I have 3x plus that. So now let's rewrite that. So this y prime goes here. C1, let me just write this guy and then let me write this under that so I won't get confused. So y prime goes here, second term. So that's a C1 e to the t cosine rot t to t. I'm just gonna move this number in front. That's fine. I don't know how far I can go here. Maybe I'll write down here. Where am I? Here? I'm just gonna move this guy up.
Why wasn't it that we couldn't combine the terms?
I don't know. I have no idea. We could.
Oh.
But for some reason, I thought there's extra t here. No. Yeah, let's combine. He's so right. So, but let's do it. Let's not do it yet. Okay, because I haven't done it. We'll do it later. Let's also plug in this guy. I didn't do it. It was not my intention. I thought I could. I can, but let's continue that way and then we'll combine at the end. So now we have to do minus 2 times what? So we combine more terms. Maybe we'll do minus 2 times what? Y. So this is my y. So I'm going to multiply this guy by what?
Minus 2.
I'm gonna multiply that guy by -2 and write it as next term here. So -2 times that,
Minus two C1 e to the t cosine rad 2t.
that, right? And lastly, what?
Minus two.
-2. And the whole thing is equal to 0. So now let's combine the like terms, as he said. So we have e to the t cosine rad 2t, e to the t cosine rad 2t, e to the t cosine rad 2t, and the rest, except this number, go together. Except that guy. So let's see if we can do that. I don't know. Should I move this 3x now, or should I do that? Well, let's just write it. So don't get too much confused. So I don't need this anymore, but I'm gonna need those guys. So we have dx plus the blue guys. It's what? C1 into the t. Let's do this C1. This is C1 minus 2C1. So it's a minus C1. Let's just write like that. Minus C1
Rad 2 C2.
plus rad 2C2 as some number, right? Times the cosine, right?
E to the t.
E to the t, thank you. Let's just, okay, let me just put what it was. And then plus the other guy. So let's see what we have here. C2 minus 2, C2. But let me write the C1 first. Minus what?
Rad 2 C1.
Rad 2 C1 minus C2. And this is the sign, right? And finally, I have minus 2, right? Equals 0. So, well, let's just move everything to the other side. So we will have 3x equals. This goes to the other side. It becomes negative. This is negative times this. It's just, this will be positive, this will be negative. Maybe not confusing. I'll just say one more time what I'm doing, or for everyone to get what I'm doing one more time. I'm moving this thing to the right side, which will make this times what? Which will make this times what? -1. And I'm just distributing -1 here. So this will become positive, that's negative, that's why I have that. If any questions, you should ask. So I switch the signs because I moved to the right side. And the same thing here. This will go on the other side, which will be times negative. That become positive, will become positive. Well,
We didn't need the YT.
hold on one. What's up?
Did we need YT?
YFT. What do you mean?
We erased it.
What was YFT?
The,
No, it's okay. If it's erased, there's no reason to talk about it. It's gone. Yeah. So if it's gone, I cannot control Z. So if we need it or not, doesn't matter. But we okay here, right? Okay. -2, right? Finally, divide by what? Divide by 3. So let's say if I multiply, I'm just gonna rewrite it here. I'm gonna multiply by 1/3, but I'm gonna change, because of the video, I'm gonna change all this. So this 3 will become what? The x that we're gonna find. And then this is gonna be 1/3 of that. There's one way to write 1/3 is this. But a lot of times people distribute this with these numbers. So for now, let me just keep it like that. And then this 1/3 people right, 1/3 C1, 1/3 that, 1/3, but let's just, so basically, and then this guy will become what? Over 3, so we got the X. And we did have the Y, right, that I erased, that's what you meant.
Yeah, but I think we kind of just have it there.
Oh, we do. Which one?
Maybe the
But
bottom.
let's write right here. So we don't, I don't want, so this one we got before, so I'm just copying with your help. Who can help me to copy the Y?
T1, e to the T.
What, did we combine together?
No, not yet.
Oh,
It's just the bottom 3 terms divided by -2.
okay, can you read the, I wrote down what Y is somewhere.
It's just that, but instead of
Okay, give me the Y.
C1 e to the T cosine √2t plus C2 e to the T sine √2t plus 1.
Like that?
Yeah.
Oh, okay. Oh, we did combine. I
Yeah.
was thinking cosine, okay, cool. So this is we got before, this is gonna, so we already done. Except we have initial conditions, so we need to figure out C1 and C2. Questions so far? Okay, to get to C1 and C2 for the initial value problem, well, it's an easy one. We have to plug in what? T is what? 0, X is 0 into the X, and then T is 0, Y is 0 into the what? Into the Y. So let's plug this in into the X. So X is 0, it's gonna be 0 equals T is 0. If T is 0, cosine of 0 is 1, e to the 0, 1, so that will be 1. This left. But sine of 0 is nicely 0, so that's gone. That is gone. Now we're plugging this into the Y. Y is 0. T is 0. Cosine of 0 is 1. E to the 0 is 1. Sine of 0 is 0. Ah. Okay. So from here we get C1 is what? -1. And we plug in here to get the C2. So if you let me, I don't like those 1/3. Before even doing that, can I multiply by 3? And then let's plug in what?
-1.
-1. Right? So that will give us, this is a run through, right? That will give us the C2. Minus, right?
Yeah.
So we got C1 and C2. I don't think I want to do it, but you should go back here and replace the what? All the C1s and C2s. That's what is left. And replace the C1s and C2s. That is what is left. Questions about this problem? From online or not online student or students? Questions? This is the 4.9. Let's just do another one of the exercises here. This is the last thing in your what exam. Basically, it's chapter 4. I'm assuming. Let me start it from 4. Yeah. Cool. Okay, so let's just go back. Yeah, here's the exercises. Let's just. Oh, there was one problem that I wanted to do only because of the algebra. The algebra was a little tricky, but not too much. I think I emailed me to look at that. If I can, maybe I put here 275. Number 7, I emailed myself because of algebra part. Number 7, let's see. Yeah, so I think it's, let's see what happens here, why I did that. These, okay. I guess we can start from here. Okay. So we have the second derivative of x equals 7. Uh, 4y plus e to the t. And then I think second derivative of y, yes, equals 4x minus e to the t. 4x minus e to the t. Checking one more time. 4y plus e to the t, 4x minus e to the t. Yeah, cool. Let's write this with the notation we did the other guys. So it's d square x minus 4y. I move the x first, and then I write the y equals this. I think if I'm not wrong, that's the way. So I don't know, it seems like it's the same, right? To eliminate x or y, whatever you want, what do you want to, it's precisely the same thing. So what do we eliminate? X, so how?
Multiply by 4 and d.
4 and d squared, right?
These
Right, cool. So that's gonna be this. This was the reason I wanted to do, because some algebra is a little, let me write what we have here and then I'll explain what we're gonna do. I want to see, first of all, I want to see what that thing is. What do you think that means? Second derivative of, yeah, then that means take the derivative of this guy, right? Which will be what? Thing, and then take the derivative again, you get what? Something. So that becomes, if you take the derivative of negative e to the t twice, you get negative e to the t. So I'm going to replace it by e to the negative t in the next step. Questions there? And sometimes people write second derivative like that. So now we add those guys together. X goes away. So we have this minus that, or that plus that. And that's a 4 e to the t. We decided this is that. So that's basically 3 e to the t, right? Basically, we have this. So now we're back to maybe undetermined coefficients to solve that. So first we'll solve the homogeneous equation. And this is the reason I wanted to do this problem. To solve that. That was the reason. Online students, are you with me?
Yeah.
Yes.
Yes. My Zoom is gone from here for some reason. Okay, cool, it's there. Cool. So some students, most of the students, I think, will do this, or some students. So I should say not say most. And then they take the fourth root. And then what do you think that some students will do? So some students will say, well, this is what? Maybe 2, because 2 to the, so some students will say that. Others will say that. But I don't want any of them. That's the problem. Because you are losing complex solutions. If the question was find only real solution, this is perfect. There are only 2 real solutions. But there are complex solutions that are lost. So that's why instead of that, we'll try to factor that. So how would I? So we use the difference of squares formula and we get what?
M squared plus 4, M squared minus 1.
And you can notice we got only solutions over this guy, but we lost these complex solutions. If it's a 4 degree, you want to have 4 solutions, even if they repeat. Okay, so now it's okay to go this way. And that will give us plus or minus that. And that will give us plus or minus what?
1.
2i. And that will give us plus or minus what? 2. So we got 4 solutions. 2 complex, 2 real. Questions so far? I think I put that in homework. I think that's the reason I wanted to discuss this. Okay. Now we can write, well, that's just for homogeneous. Let's write that homogeneous solution of y. Okay, I want to hit this one, but I don't want that. So now y complementary homogeneous solution. Let's start from this one. For these guys, I will have what?
E to the 2t. C1 e to the 2t. Minus 2t.
Right. And for the other one, we compare this to alpha plus or minus beta I, and now alpha will be 0, and beta will be what? 2. So we apply the formula e to the alpha t C3, because 1 and 2 are busy, cosine of beta, right? T plus C4 sine of beta T. And of course, I will change it to 1 if you let me know. Questions there? I will change e to the 0 to a 1 by doing this. So we got yc, but we still need the yp because our equation is this guy. It's non-homogeneous. So we have to look at the right side. We solve for the 0. So right side is this. So we'll choose the yp will be, for this 3, we take what? A, and we keep that. Matches or no matches? No matches. What would be a match? If this were 2t, that would be a match. So we need extra what? T. Questions? But we don't have a match because this is not a 2t, it's a t. So we keep the yp the way it is. But to plug it in here, we have the fourth derivative. But e is an easy derivative to take. Well, the derivative of this guy will be what? Same thing all the way, and again, it's gonna be same thing, same thing, same thing. The fourth derivative also will be what? Same. Plug in. Plug in this blue equation. Let me plug in here. Plug in there. So we have fourth derivative, which is this, minus y is the same, equals this. That will become what? This. So we lose the undetermined coefficient. This guy has to be 3, which means A has to be what? Minus 1. Which means YP should be A times this, should be this. And how do I get the Y? Okay, let me. Yeah, so Y has to be YC plus YP, is that right? Now, if you let me to cheat, I'll write Y equals, this is YC plus what?
Minus
One. Yeah, minus, what is it?
150 to
That will be my Y. This is YC plus YP. Now we need to find the X. Choosing the easiest one, I go with which one? This guy, because it has an X, this has a second derivative of X. It's easy to solve for X. But in order to plug in the Y there, I need the second derivative. So we'll find the second derivative of this guy. But these are not too hard for cosines. To differentiate, let's do that. So we find the derivative of this guy, which is what?
2C1 e to the 2t plus 2C2 e minus 2C2
And the other guy, right?
plus 2C3 cosine 2t
That's right.
plus 2C4 cosine 2t minus 150.
Right, and let's do one more time.
Two t plus 4 C2 e to the minus 2t 4 C3 cosine 2t minus 4
But I should go to here. I don't want to do that. I want to first, let's do this. Let's not do that this time. Maybe I just realized it would be much easier if we solve this for X and then plug in. Right? You see, you come up with something. Okay, sorry. So let's solve this for X and then plug that the Y's. Cool. So if I solve that for X, maybe I will have negative 4X equals maybe this, right? Divide by negative 4 to get the X. So let me write 1/4 second. Let me change this to second derivative y plus 1/4 times 1. So let's plug in the second derivative in here, which means multiply it by what? 1/4. So this guy, oh, is that, did we check combine? Nothing combined. So multiply this guy by what? 1/4. So x equals 1/4 times that. So the force cancel.
C1 e to the 2t plus C2 e to the minus 2t but minus C3 cosine 2t minus C4 sine 2t minus 1/20 e to the t.
Plus this guy, right?
Yeah.
The only thing you need to do to replace this by what? Maybe times 5 here, right?
Yeah.
That's a 5 minus 1. So it's a 4/20. Or maybe 1/1. 5? 4/20. And that's your x, and we got the y up here, I think. So again, the only reason I wanted to do this, I thought it was a good practice, but there was an equation where most of the students would solve it only real without complex. Questions, comments, remarks?